In this video, you'll learn about a topic that's frequently misunderstood: clocking in networked audio. Dante automates most clocking decisions to ensure that you'll get good results, but a clear understanding of how clocking works and what might go wrong is vital when troubleshooting an installation. Let's look at clocking in Dante systems. If you've dealt with digital audio before, then you know that a clock is at the heart of how it works. In all digital audio, signals are represented as a series of values occurring at regular intervals of time. It is absolutely critical that the clock that defines these intervals be rock steady in order to avoid jitter, a type of error that generates unwanted non-harmonic distortion to the signal. In early digital transport systems, jitter was a problem because the clock and the signal shared a single cable that was susceptible to phase shift and time delays. In a Dante system, audio clocks are recreated at each endpoint and then synchronized over the network. This approach eliminates jitter, but demands that we understand how the clocking works. In all Dante networks, one device serves as the master clock. This device is responsible for maintaining synchronization with all the other Dante devices. In most cases, it does not matter which Dante device takes on this role, and by default, Dante elects a master clock on its own with no input from the user. All other Dante devices act as slaves to the master clock. They each have their own internal clock, and each makes small adjustments in order to stay in sync with the master clock. The clock synchronization data is sent over the network using precision timestamps, ensuring that all Dante devices remain synced to within 1 microsecond, an incredibly small number. By default, a network of Dante devices elects a master clock upon startup. This election is based upon tests of network connectivity as well as a tiebreaker criterion of hardware address. In most situations, a Dante network will elect the same master clock every time. Note that it is not possible for a Dante network to have more than one master clock at a time. The system will not allow that condition to occur. If you wish the master clock to always be a particular device, you may designate it as a preferred master in Dante Controller. This effectively rigs the election for that device to win. An example where this might be useful is in a network that has a core mixer and then many other devices that are attached at different times. By setting the mixer to be the preferred master, you can ensure that the master clock doesn't change, even as you add and subtract other devices. In some digital systems, loss of a clock is disastrous, resulting in a complete loss of audio or terrible noise. Because each Dante device is capable of being a master clock, the failure of a Dante master simply means that a new master will be automatically selected by the system, even if the failure is in the preferred master. This change is made in a fraction of a second without any interruption of audio. Additionally, if clock synchronization fails for a device, that device is instantly muted to prevent bad audio from reaching an audience. Once clock synchronization is restored, the device again comes online. Clock sync failures are nearly always the result of a network problem, such as a switch with slow, non-gigabit links. Much of the time, the automatic clock settings in Dante are more than adequate. If you wish to make some changes, use the Clock Status tab in Dante Controller. The Clock Status tab displays a table of all your connected Dante devices and shows status for sync, meaning that the device is properly synced to a master, mute, what happens when a device falls out of sync, clock source, meaning a Dante clock or one from a third-party product, and the master-slave status of both the primary and secondary links. In addition to these status notifications, Dante Controller allows you to set 2 additional parameters: preferred master and enable sync to external. If you wish a device to be the master for a network, enable the preferred master checkbox for that device and no others. That device will then assume the master clock role. You may select multiple preferred masters. This forces the master clock election process to only consider those devices, excluding others. The enable sync to external setting is only used when one needs to use the internal clock of a console or another product that is simultaneously hosting other digital interfaces, such as MADI or CobraNet. We hope that this video has helped you to understand this critical area of audio networking. And thanks for watching.